My name is Mofi, and welcome to this CNCF ChatLoopBackOff stream. I work for Google. I'm a developer relations engineer. I do a bunch of things in the Kubernetes community, including working in the HCD project a little bit. These days, my focus mostly is around running AI ML workload on Kubernetes and mainly GKE. But today, we're not talking about AI ML or Kubernetes for that matter. Today, what we're talking about is OpenTelemetry. So if you're already familiar with OpenTelemetry, let me know in the chat that how you use it, what kind of things you like about it. If you're new to OpenTelemetry, we're going to be learning together. We're going to be trying out what OpenTelemetry is all about and try to run this maybe by the end of this hour-ish stream to see how OpenTelemetry works, how it feels to use, and how the documentation looks like and how to get started as either a developer changing your code to send some metrics out to some system, or as an ops person collecting those metrics and showcasing them either as a dashboard or creating alerts, whatever we can do with OpenTelemetry. So if we switch to the screen real quick, we can have our screen share. Here we go. Thanks, magical person in the background, for handling all of this. We have this is the homepage of OpenTelemetry. And before we jump in, again, I am joining in from New York. It's Friday, April 26th. So in the future, the things we're seeing here might be different, but for the most part, OpenTelemetry is pretty stable. So I don't really expect things to change that much more drastically. So OpenTelemetry from their website, what they claim to be is a high quality, ubiquitous, and portable telemetry to enable effective observability. Again, I always find this kind of big name titles to be kind of confusing. Like it's a banner, it's a statement they have made about what they are, but what does it even mean? I honestly don't even know what ubiquitous the word even means. Actually, I'm gonna look it up. Ubiquitous. It means found everywhere. Okay, so where OpenTelemetry's claim is they're found everywhere, which may be true because I have seen telemetry everywhere these days. Portable, which I can agree. Again, OpenTelemetry runs on Kubernetes. Kubernetes itself is portable. I think you can run OpenTelemetry by itself as well, but again, portability definitely makes sense. High quality, that's something we'll test out and we'll be the judge of that in a minute. And enable effective observability. So I think for the longest time in application development, observability basically meant the way we like our logs and other things. And over the last 10-ish years, like with the movement of DevOps and like the need to understand how complex our application has gotten, observability probably has taken on more tasks. And I don't think any talk or any conversation about CNCF can be done effectively without taking a look at the CNCF landscape. And there has been a landscape. This is landscape V2, I believe, which is the latest update on the UI, which looks a bit cleaner, but the number of projects in CNCF landscape is just, wow, it's a lot of projects. The project we're looking at today is OpenTelemetry that sits right here, which is a CNCF incubating project, which means it is, again, it's accepted by CNCF, but it hasn't graduated yet. There are a bunch of steps. This project has been around for about 5 years now. Again, there are different levels of graduating from CNCF as well as different things you need to finish. Some projects actually go through the process a little bit quicker than others, but OpenTelemetry is seems pretty healthy in terms of like their GitHub pages. So they have a few different libraries here. You can see the .NET SDK, Python SDK, collectors, Java instrumentation. So they have a bunch of sub projects under the OpenTelemetry project there. All right, so OpenTelemetry sits here. So OpenTelemetry itself, the history of it, there I found like a nice little website that kind of talks about a timeline of some sort that looks at how OpenTelemetry came to be. And OpenTelemetry is a project that is basically a combination of two separate CNCF projects. One was OpenTracing and one is OpenCensus, which combined together as OpenTelemetry in 2019. And soon after that, OpenTracing was archived. So OpenTracing right now is an archived project, which again, a lot of the OpenTelemetry's DNA comes from open tracing. So OpenTelemetry, let's take a look at the project. What's that about? Let's learn more. So OpenTelemetry talks about is an observability framework and toolkit designed to create and manage telemetry data, such as traces, metrics, and logs. Now, logs is probably the most common one. Pretty much everybody, including myself, understand pretty easily. You write your application, and certain points, you write something down as it is happening, some data, some failure, or some information as you'd like to kind of create this breadcrumb of things that are happening as the application is running. Metrics, on the other hand, it's also fairly understandable, but it is not something your application writes. It's more about your application creates these signals as things are happening. If you're a web server, metrics could be something like, I am currently handling, I don't know, 55 concurrent requests right at this moment. So every few seconds, you write the state of your application out to somewhere so that someone can take a look and have a time series information about how your application was behaving throughout time. They also have more data about, okay, oh yeah, that's a good definition. A measurement captured in time. And it could be measurement of any certain kind. And this depends on what you are trying to capture, right? So if your application is, you are finding your application is not being able to handle enough requests, or it is failing on a certain time during the day, if you write the right metrics, then you can go back and say, okay, 8:55 on a Thursday, my whole application crashed. What was the application doing at the time, right? Like it was serving 1,000 requests. Usually we do only 100. Something happened. Either we got a lot of new customers at that hour, or we got attacked by a certain entity. All of a sudden, our application has crashed because we have too many requests coming in. And every time you write these events, again, how quickly you write and how much you write depends on your need and how much you are willing to like store that information. For metrics collection, there are other CNCF projects that can do things like this, like Prometheus can do it. But with OpenTelemetry, you could kind of, the claim is you can have OpenTelemetry do both logs, metrics, and traces. And the last one in this list is traces. So what is traces? So traces is that my application, when you have someone go to a website and click a button, from that user's point of view, they just clicked a button. But in the back end, a bunch of things might have happened. You click a button to log in, that might go to the authentication server, get yourself a token. That token comes back, token gets validated, and then you get yourself like a session token of some kind. From a user's point of view, they just clicked one button, but in the application, there might have been like bunch of calls back and forth to the server before that login action was completed. So you could represent all of that via traces. We will probably take a look at like a trace if there is a demo here somewhere, but generally a trace would be something like a waterfall view of the flow of the entire interaction through your application. And how detailed we get is something represented by something called spans. Spans would be some like a unique unit of action that is happening within the whole interaction in my application. And then I can go deeper into, okay, this one call to my database is taking really long, right? Like this is throughout my interaction with my application, I have this one interaction with my database that's taking really, really long. Why is that happening? That could be a number of reasons. That could be that my database versus my application are geolocated like far away. So we're having a lot of network cost of going over the Atlantic to talk to a database that is living in somewhere, let's say in Europe, and my application users are in US. That could be one reason. Another reason could be that my SQL query that I have written has not been optimized. So every time I'm trying to make a database query, I'm having to join like 18 different tables. So the table join is very slow. Or it could literally be my table has gotten too big. I did not index properly. But all of these things, if you're just looking at the total request time, you are learning that the request takes 3 seconds. With traces, now you can dive deeper. You can understand that, okay, this part of my application is taking longer. This authentication mechanism takes longer, or this validation of regex query takes longer. And without that knowledge, it's very difficult to optimize or improve performance. Traces also can help you like dive deeper into the exact error, exactly what part of your code is failing something. So traces is like done well. Traces can be a great tool for understanding exactly how and why your application behaves the way it behaves. In certain use cases, I have seen kind of good logging as almost like an alternative to traces. But as the application gets more and more complex, I don't think there is anything as good that exists as traces to give you a like a proper flow through your application. And like better tools of observability will also probably connect your traces and logs and metrics all together to create like a cohesive view of what is exactly happening. So each trace points would also be correlated to some sort of log, or vice versa. Like each log that you see can be then traced back to a specific trace or a specific span that is happening. Looks like OpenTelemetry kind of creates this JSON representation of each of these traces. So it gives a name, a unique context trace ID and span ID. You have some sort of a start and end time. That is the waterfall view of how long each of these traces are taking. Attributes, you can add random attributes, like in this case, what HTTP route this trace was generated for. Events, you can create random events, or like events that you would understand in your system. And yeah, and so the spans can also, like, this is not necessarily something OpenTelemetry itself made up. This is generally about traces and spans. When you have a span can be a parent of another span. So you can have a larger span that has multiple smaller spans within, or you could have a drill down view of like multiple spans making up a full view. And you could then probably would have like this parent information. So which span did this span originate from, and things like that. Okay, so you have a lot of information about what kind of signals that OpenTelemetry handle. There is observability primer, talks about what observability is. We kind of talked about that already. We have reliability and metrics. So in again, I work for a cloud. Also, like any kind of service that you kind of pay for, you want to understand that what like the number of nines of reliability guarantee your provider is providing you. If you are a platform engineer and you are the seller of this service to the rest of the company, you also provide certain level of reliability guarantees. You could say something like, okay, in a given week, you can expect to lose the service about 1 hour while we do maintenance and other things, right? And the higher the reliability you want, the more information you need, so that when something does go wrong, you can quickly go back and fix it. So reliability is the service doing what is the user expecting it to be doing, right? So if a user is trying to buy something from your shop, if they click a button to add to their card, then put their credit card, and they want the system to be sending them the item they just paid for. So that's like in a very overarching definition of what reliability means. Again, I don't think any system exists that could have 100% uptime all the time. So like pretty much anywhere you go, when you ask for reliable service, like the SLO, SLIs that you're looking for, the question becomes how many nines, right? So SLO, understanding. So yeah, you have SLA, that service level agreement. SLO is service level objective, and SLI is service level indicator. So these are the three things. I just wanted to know, what does 99.99 mean in SLO, right? Okay. So 99 if you have 29, you're basically saying in a given year, you're going to have about 52 minutes of downtime, right? Like less than an hour in a whole year. That's a very high SLA. What if we say 3 nines? Then it becomes about 5 minutes in a given year. With 4 nines, you're talking about like 31 seconds. So every time I hear something like, oh, we have like a 4 nines of SLA or something, that always sounds super bizarre to me. Like 31 second in a given year. I don't know what that even means, but I do know what it means. It means 31 seconds of downtime in a given year. I think this is more about like creating these contracts and deals, and when the companies breach that contract, you then have difference of like, you can have some level of compensation for losing out on the service beyond this. Like this is like what, 6 nines? Wait, that's 4 nines. Oh yeah, 99.9. That's 6 nines, right? If I go like 8 nines, after that is still 31 seconds. I don't think it is. Ooh. If you just say 99%, that is about 3 days of downtime. That's a lot. So I mean, for like a healthy service, I think 4 nines is really good. 5 or 6 9 is probably like really, really good, and it's going to be extremely difficult to keep a software system up entirely 100% of the time, but we can get close. All right, we digress. Let's go back. Metrics, we're talking about aggregation over a period of time, as we talked about. These are information that your application is generating about things like how many requests it's serving, how much resource it's using, like how much CPU it's using, how much GPU or memory, whatever like a resource your application uses. And so that would be the metrics there. SLI is the indicator. So a good SLI measures your service from the perspective of your user. Um, so one of the SLI could be like like the time to first byte. If you're trying to like load up a website, when you first click, like type in your browser a new web page and click enter, you are looking at like content showing up on the web page. How long does it take on average to get the first bit of content on the page? There are some um, metrics and numbers people have looked at where like if it takes more than like 5 seconds of difference results in about 20% of the customer loss. I think that was a data like a research done by Amazon for the amazon.com webpage, where like if the load time between 10 second and 15 second was literally losing 20% of their business. At Amazon scale, 20% of the business is like billions of dollars, right? So that's a lot. Service level objective is something you set, like what you set as, okay, I want to have this much. So again, these are things that are useful SLIs and SLOs. Where does OpenTelemetry fit in all this? Now, OpenTelemetry allows you to have is a tool that lets you build out both from the dev side with like code, where you can create this metrics out as well as these traces and logs out, and from the ops side build out tools where you can collect this and store them and represent them in different ways. If I go back to the original page of OpenTelemetry, so get started based on your role. This is something I actually quite enjoy about this kind of tools, because a lot of these tools are works in both ways. It works for both the user who is writing code and the user who is collecting and using these metrics. So dev comes first. So let's try in this list dev and what they want us to do in terms of getting started as a developer. Looks like you can have pretty much any language that would probably be using. What are they missing? They have Python, obviously. They have Java. They have Go, which I like. C++, .NET, JavaScript, TypeScript, PHP, Rust, Swift. Yeah, I don't see any major missing language. So pretty much anything people would be using these days are probably covered. I'm thinking of like any other language that people would probably want to use. Lua, Perl, and Julia. They have following languages. Okay. So these ones don't exist yet, but there's a request to create a SIG. So if there are folks in this call or watching this video in the future that wants to see, okay, I'm a big user of Lua, I would like to have a SDK for Lua for OpenTelemetry. There is a existing request for a Lua SIG, and we're just like, I think they're just gauging the interest of how many people would want it. And this is open since 2022, so it does not look like there is a big interest in that. If there was, there probably would be some work done. Oh no, there are probably some work happening here as well. So there is an OpenTelemetry Lua, but it looks like it is done by a few folks. That's not part of OpenTelemetry itself yet. And again, looks pretty active. Some things done even 2 weeks ago. So yeah, even if you're using Lua, you might be able to find things to do yet. Julia or Parl, same idea. Opened around the same time. And yeah, there are some like third party individuals that have created this once, but it's not as common. What I do want to do, though, is look at the language I really enjoy, Go in this case. And I want to see like an example application of creating metrics and such in Go. All right. So no time like the present. I would like to quickly create a Go project that is using, I'm going to bump up the font a few notches and actually switch the profile to demo. It'll be easier to see for the folks, I think. And move this over here, clear this out. Okay. Okay, so I am in a folder called OpenTelemetry-Go-Example and Go mod init. I think they called it dice. I will call it same and open up VS Code. Fantastic. And then I need a new main.go file. And let's go grab some code and see what we can do here. So it looks like, again, we're creating a very simple HTTP listen and serve here. So we have this. Once it saves. Okay, and we need this handler roll dice, which we haven't copied yet. So let's go grab roll dice. And let's grab that here, bump up the font quite a bit, easier to see. And once all the import has been completed, we can probably try and run this. I'm going to say go run in.go. And allow internet connections. And this is running on, it doesn't print anything, but it's running on port 8080. So I'm going to split this. I'm going to do curl localhost 8080/roll dice. I got a 1. Do it again, got a 4. Do it again, got a 5. Again, looks like what it does, it just generates a random number between 1 and 6. And every time you call into this, it gives us number that like converts that into string and writes that into this. And if it, for some reason, if it were to fail in converting, it would log this printf. So it doesn't print anything when it succeeds. It only prints when it fails. Okay, sounds good. So let's see what we can do to add some telemetry and instrumentation on it. Okay, it looks like we're installing the following package. It kind of feels bad to import this much things on a simple application. But again, these are the same import we need for however much complex our application would get. So let's install this here. So we're installing the OTel library. We're doing exporters of standard out metric, standard out trace. We are also installing propagation, SDK metric, SDK resource, SDK trace, semconv 1.2.24.0. I don't know what semconv is. And finally, we're getting instrumentation, net HTTP, OTel HTTP. So it looks like there's a wrapper on net HTTP that is meant to be able to create traces for OpenTelemetry. All right. Let's just say we trust all of this for the time being. This is all coming from the OpenTelemetry Go package. So again, I'm going to say they're all good. But again, I think this should all be open source code that we can go take a look yourself if you, for some reason, would not want to directly trust something like this. Okay, so now what we're doing here, we're going to initialize the OpenTelemetry SDK. This is required for any application that exports telemetry. Okay, we're going to create a otel.go file, which all this stuff, I'm going to just copy it, then take a look at what this code does. And okay, I'm going to kill this server, lower this a little bit, and create a file called otel.go. Paste this, and let's take a look what it is doing. Set up OTel SDK. Okay. All right. Okay, it does not return anything. That's fine. It just takes the context, takes a shutdown function, which is called error. and which returns, shutdown function called shutdown that takes a context, returns an error, also returns an error called error. Okay. Okay, we have the shutdown function there. We have a propagator created, text map propagator from hotel created there. Okay. All right, then you have a new propagator created. We are going to trace context and add baggage. What does baggage stand for? It's a baggage format. I'm not familiar with the baggage format, but I'll take a look in a second. The trace context is here. Okay. And then we create a new trace provider. And we have, it's going to be on the standard out with pretty print. Good. And we're going to give a batch timeout of a second. Sounds good. And we have meter provider. What does this do? Meter provider handles the creation and coordination of meters. All meters created by meter provider will be associated with the same resource, have the same views applied to them, and have their produced metrics telemetry passed to the configured readers. Not super sure what the meter provider does just yet, but we'll take a look. We have a timeout interval of 3 seconds. Default is 1 minute. Again, we're setting it to 3 seconds because we want to collect much quicker. That sounds good. All right, let's move on to the next bit. We're going to instrument the HTTP server. Okay. So by default, right now, our application does not really like do anything with the data. We just set up this OTel file with all the OpenTelemetry configuration for all the different tracers, but we're not using it anywhere. So what we want to do now is we're going to create a new server of some kind, and then every time a request comes, we want to handle the functions based on what we had going. So let's copy all of this code. And I'm guessing we're going to keep our roll dice function as it were and replace everything here. And again, Go is really good at importing the necessary things when it sees the code there. So everything else should be done exactly the same way. So one of the things we're doing here, we're in the main, we're calling this run function, which we create here to wrap all the functionality within that so that we can have, if there's an error there, we can just log out the error. This is done to, okay, we're catching the interrupt. So Control C is going to create a OS interrupt. So if there is a signal there, we can call stop. And then we pass this context to set up the OTel SDK. Again, the OTel SDK gets created by the setup OTel SDK that takes the context, and we get this context from the signal notify. So you can use the same signal to then pass a context.cancel onto setup OTel SDK, OpenTelemetry SDK. Cool. All right, we have a defar. If there is a shutdown, we can basically, as the function exits, we can print out some of these errors as they're happening. We create a new HTTP server on the same address that we had before. We create some read and write timeout, create a new HTTP handler for the handler. And for any errors that are getting created, we create a new channel. And then we create a new Go routine that's going to do listen and serve. And then we select on all the channels if there's either context done, which is coming from Control C, so we call stop, or any kind of serve error that comes from listen and serve. So yeah, this is a little bit of like a convoluted way to create that service, but this will definitely work, what we are trying to do. And this will also be more robust in terms of handling error from either coming from the SDK, the server, or us manually calling Control C. Awesome. Okay, so new HTTP handler, we create a new one. Oh, that's the one we are passing here, the handle as the handler. We create a new servmux. We have a handle func, which is gonna match the pattern. So this is what we're using to wrap our calls here with handle func. we're wrapping that with the OTel HTTP. So we can now then pass all the context to the spans. I guess this is helping us not to have to write the spans manually. We could just have OTel HTTP new handler and we call everything on mux. And then we have our roll dice HTTP handle func, which we're wrapping with this new handle func function that takes in a pattern and a handler func. Cool. It's almost like a middleware use case that is happening here. Awesome. So that all looks good. Let's see what they want us to do next. They want us to, at this point, okay, looks like they want us to add more manual traces and such. Okay. Oh, the meter is basically for metrics. Got it. Okay, so we're going to create a new file called rolldice.go. Rolldice.go, and we're going to copy in this code and try to see what that code is doing. Lower this a little bit. So this is going to be an error because we have a roll dice defined twice. So I'm going to get rid of this definition of roll dice from our main.go and look at this roll dice go file real quick. What are we doing here? We have a tracer, we have a meter, and a roll counter, which is a metric.int64 counter. So this is going to be like a Prometheus metrics that's going to count every time we do roll. It's going to count how many rolls has been done. Yeah. Or it is just getting the number of rolls by roll value. That's not a great description. Number of roll. I'll see what that metrics looks like in a second, and we'll see if this description makes any sense. Okay. We have this roll dice definition. This one, again, our actual code is basically this bit that was converting our roll. So we have this line and this line. That was the previous code. What we're adding here is a span. So we're starting a tracer. We're adding the context and adding the name roll to it. So tracer.start takes in the context and the span name. So we're going to giving a new span name of roll. And then roll value attribute, that is the metric we're trying to add, roll.value. And so roll value attribute and count, we're adding 1 to our metric. So every time we roll, we want to increase our roll counter by 1. And the rest is exactly what it was happening before. All right, that looks like that all still makes sense to me. And we're going to move on. Okay, there are some flags we're exporting. So let's copy this in. Go mod tidy, that should... Go mod tidy would basically look at our imports and our Go module file like here. And if something is not being used, we'll clean that up. Or if we need to download something new, we'll do that as well. So this is now running. And it is asking me if I want to give it permission to run on network. Yes. Go ahead. All right. Every few seconds, we're generating some sort of metric. Something is running every 3 seconds. I think that's the meter that is pushing that metric out. I want to take a look at one of them. What does that look like? So I could do echo and then pass it to JQ. Nope. What does it not like? Oh, quotes, right? Echo. There you go. So I'm just like using JQ to sort out this one so that it looks a little bit nicer to read. So resource, there is a bunch of things in the resource. You have service name, service version. Service name is Dice. Telemetry SDK language is Go. Telemetry SDK name is OpenTelemetry. SDK version is 126. So these are all the things that are being pushed out every 3 seconds or so. In your application, I think that number is coming from this 3-second value here. Yep, meter, this one. Usually it probably gets pushed out every minute or so. Okay, so we run the application. We want to see, go to roll dice. If we just go to roll dice, we'll see that we get 2, we get 5, we get 5 again, we get 5 again, 6, 2, 3. Okay, so all of these numbers generate some data. And then how do I go about seeing the metrics. So we did all of that. I want to see exporting this data out. Oh, every time I do it, we should see a dice.roles thing happening. Okay, we did not see that. Oh boy, this is a lot. I'm gonna close this one. So this is a bit noisy, but wish it was a bit easier to read. I think it is this, and I'm gonna try to. Oh, that's a lot of data. Okay. Okay. We are doing a lot of collecting all the metrics that were here. Okay, cool. Here you go. HTTP method was get. There was, status code was 404. That's not good. Port was 8080. That's what we did. That was good. Here you go. Roll dice. We got, the 404 might have been on the fav icon thing. Value of 16. That does not look like anything. Okay. I just want to see what does like one single metric. So these are the metrics. I want to see the spans if we generated any. They're still the metrics. So this is the scope metrics. This is the original, like the base stuff that we put in. So our application is generating metrics. It is a lot of data, and parsing JSON by just looking at it is not a skill set that I possess. So, but it looks like some of the data we are pushing out is getting collected by the metrics collector, which is cool. Okay. So you have this, for each of the metric, you have this bucket collector for value 0 and up to 5 and up to 10. And what we will see that most of the values that we did was between 1 and 5. So they're here. If we did something like 6 would show up here, and every other bucket would be empty. I guess we can manually control the bucket using code, but the example does not show it yet. All right. So that was just like a simple application written in Go that did generated the metrics, but we're not really doing anything with the metrics just yet. So to do something with the metrics, what we need to understand is, so you have the instrumentation. So we looked at all of this. That's cool. We have different libraries for doing this. Or what is this? We can go to, okay. And we have a bunch of available packages that we can find. Okay. We looked at, I think we used a couple of metrics, but there are all of them that are listed here. So OTLP to an endpoint. So OTLP is, what does OTLP stand for? Let's look that up. OTLP. OTLP stands for OpenTelemetry Protocol. So OpenTelemetry Protocol is a protocol of defining your metrics and traces and logs in a format that other tools that also understand the OTLP specification now can understand and read. One such endpoint would be something like Prometheus. Prometheus can understand OTLP exports, as well as Jaeger. So Jaeger can also understand OTLP metrics. What is Prometheus and Jaeger, you ask? Prometheus and Jaeger are both CNCF graduate projects. So Jaeger is a project that is for distributed tracing. It's part of observability, and it is like a very common tool that you would see that where you can see traces and such as your application is generating more and more traffic. So there are other resources like sampling. So sampling would also talk about something like how often are you collecting this metric, right? For collecting every request is useful, but it's also will slow down your application, will be expensive to store all this different information, right? But if you collect like once a day, then you're probably missing out on important information. So there is this balance of what you are doing with it. Either you are collecting too much or too little, right? So if you're collecting too much, then it's going to be expensive. It's going to slow down application. Also, you might just collect too much data where you have to collect. Understanding exactly what's happening, it then becomes more expensive because you have to shift through all this data or have a dashboard that is looking through things. If you're collecting too little, like once a day, then again, you miss out. So there is a right balance between them, and it depends on how, like your application itself, how much traffic you get, what kind of time traffic you get, and things like that. So it is more of a trial and error thing. You probably want to look at, for most use cases, in my experience, anywhere between like 30 seconds to 5 minutes has been probably a good starting point. And from there, you can then turn the knob to do more if you're missing out on information, or do less if you feel like you are getting too much, right? So like if you say 0.5, like for example, this number 0.5, you're saying collect only half the traces that get generated. So for most of my things that I have done, I have seen something along the line of like 0.2 to 0.3 has been a decent starting point, and from then we can go either direction to collect less or more. There are a bunch of examples in Go. The one we just saw is called Dice, that is here. We just ran that one. There is a bunch of other like hotel collector that we'll talk about, having them collected to Prometheus or Jaeger as well. But instead of looking at the Go example, continue looking at the Go example, what I want to do is try to run the demo they provide here. So what they have here is like a fairly complex service with a front end where you can load generate with the load generating service, or like manually go there over the internet. You have a front end service that has an ad service that talks to ad service, checkout service, shipping, recommendation, cart. So all these different services. And each of these services is written in a different language. So pretty much any language you can think of you need to support is probably already being supported here. So I want to go and try to deploy it myself, not development or Docker. I want to run this using Kubernetes if I can. Okay, here you go. Kubernetes. Okay, that's the example of running this in Kubernetes. And what I'm going to do is run this using this OpenTelemetry help chart. As a pre-step, and to save some time for me, what I have done is created a Kubernetes cluster on GKE. It's again pretty much a standard Kubernetes cluster with 3 nodes. So I'm gonna go and connect to that one. And I have these cluster nodes. I can do kubectl get nodes. I have 3 nodes right here. I created like an hour ago, and I'm gonna say kubectl get PO. There is no pods or anything that is there. So I have a cluster that I can run all these commands against. So let's add this Helm repo. Again, Helm is a way to package your application in a way that other people can go and access. So if you're not familiar with Helm, again, Helm is also a CNCF project. I think it's a CNCF project, should be. Let's look it up where Helm is. Helm. Helm is not in the list, or I searched it wrong. There you go. It's a CNCF graduate project in the app definition and development. Is there anything else in that world of Helm that does similar things to Helm? There are probably a few different ways, but Helm is the first one right here. Helm is app definition. So you have, so if we look at helm.io, nope, that's not a. What is the web page for Helm? Helm.sh. Okay, Helm is the best way to find, share, and use software built for Kubernetes. Helm is a great tool, right? Like you could package all your application. You can have also like this Go templating to replace variables and other things. So you can package applications. I think the best use case for Helm are installing like common software, like a database or like some sort of like a storage interface or anything. So we could then manually change certain variables using a values.yaml file. Again, if you're not using Helm or not familiar with Helm, I don't know if we have a ChatLoopBackOff episode of Helm. If not, Jiffy, if you're watching this later, do one. Helm is awesome. People should learn more about it. Okay, so we're gonna use Helm to add this. First, we're gonna use Helm repo add to add this chart onto our cluster. Oh, I had 2 copies. Okay. Okay, OpenTelemetry has been added to repository. Next thing we want to do is we're going to install my hotel demo. I want to change the name. Actually, sure, it's my hotel demo. And this is going to go ahead and install a bunch of things on my cluster in the right. If it needs to create new namespaces, it's going to create new namespaces, but it's going to go ahead and should install a bunch of things onto my cluster. We'll have to wait a second to see if it did anything. Ah, here you go. So it has gone and done all of this. And it is telling us we can go ahead and set up some port forwarding to the service. So if you do keep control, get PO, I should see a bunch of services are getting created. We have this accounting service, ad service, card service, Kafka load generator. So all of these are getting created. They are not ready yet. They will be in a second. Most of them are already running. Some of them are still. So I'm waiting on the load generator, which is important because I want to generate load so that we can see those traces. And the fraud detection service also is waiting. All right, only the checkout service and accounting service remain, or only the checkout service remain. Okay, now all of them are running except for the Prometheus server, which has 0 of 1 ready. We'll just say that will probably be fine eventually. So we'll move on and do other things. So number one thing is kube control get service to see what services that we have. We have many of them. I want to see them all. We have that service and all of this. The one service we do really want to get access to is the front end. We can see it. We have Grafana get already deployed. Jaeger already got deployed. So we can go see kind of the nice traces. Grafana would show us those nice logs and metrics as a dashboard. If the Prometheus service is also working, we're going to be able to see those metrics too. Okay, so I want to go get access to. I'm going to set up this front-end proxy by running this port forward. All right. So that is looking good. I want to go to the web store itself by going to localhost port 8080. Let's go ahead and do that. All right. So this is the web page. Again, the content of the web page is probably not that important, but again, it's a nice little web page they have built out. I can go shopping, and it's a shop for a bunch of telescopes, which is again appropriate because OpenTelemetry's logo is a telescope. I guess that was the whole point of this. So I can go look for a telescope that I want. This looks like really fancy. I want to get this one. Add to cart. Looks great. All of this is filled out. Yes, someone@example.com is definitely my email address. That is a credit card number auto-generated. Pretty happy with all of that. I'm going to just send it over to 1600 Amphitheater Parkway. Is that the Google's address? I think it's Google's headquarters, right? Yeah, it is the Google headquarters. Cool. I think one of my coworker might have had something to do with adding this address as the default address. That's a fun little Easter egg hidden there. That's fun. But we did a bunch of things, and I think load generator itself is also generating a bunch of load underneath. Let's go see what that meant for all of our application. What can we go see? I want to go see the Grafana dashboard, which would take us and be able to see some dashboards if we can. Here we are. And let's see if we have any dashboards already created. Okay, OpenTelemetry collector is doing things. It's collecting stuff. Cool. Span metrics demo dashboard. Okay, payment service has a 15-second latency. Again, I think this is designed so that we can go see this. So we can start seeing things like, okay, all of my services are doing fairly well. They're in the millisecond range. All of a sudden, one thing is adding 15 seconds of latency. This might not be an actual problem. Again, payment service, usually what you have is payment service talking to some third-party payment provider, like uh, I'm blanking completely on any of the payment provider, or Visa, MasterCard, or something like Stripe even that we're talking to. So this might not mean it's bad, but it could be like if you're, so most metrics and telemetry means something in association with other things. If it's usually 15 seconds and it stays at 15 seconds, and that's the service level agreement you have with, or this is the kind of expectation you have, there's nothing wrong. That's fine. But if it's usually 1 second and all of a sudden taking 15 seconds, all of a sudden now you have to think about what is going wrong. All right, we looked at the Grafana dashboard. The other two things we can also take a look at is, one is load gen. We can generate a bunch of load very quickly, I think. So this is using Locust, I think. Locust is like a Python application. The load gen is not available. Okay. Either I crashed something or broke something. Either way, we're gonna move on. We're gonna see what happened with load generator in a second. I want to actually, the thing I wanted to see the most is the Jaeger UI, and they're both down. Uh-oh. Okay, crashed something. My port forwarding stopped. Why? No idea. Not gonna concern myself with it. I'm gonna just go back. Okay, here you go. That worked. This is working. Jaeger UI. Jaeger is here. Yay. Okay, now you can see. So what happens with Jaeger is, as you're sending this metrics, Jaeger will build out this map of all these services that you have. So as services call each other, you can actually build out, Jaeger automatically builds out this map. This is not a map that is manually built out by a user or with some code. So what you can see here, that load generator and Jaeger all-in-one and front-end web all talking to front-end proxy, which talks to front-end, which talks to all these 6 services. And your checkout service talks to your payment, fraud detection, email service, accounting service. And you have this recommendation service that talks to product service catalog. So all of this view is actually built out by Jaeger automatically as it is seeing requests come through. So as it sees that front-end proxy only calls it front-end service or Jaeger all-in-one, this view has been built over time or after some load has been generated. So let's take a look at one of the services that we saw that was very slow. What was that service? That was your payment service. I want to take a look at the payment service and see what's going wrong with the payment service there. And I want to just find some statuses. So 37 milliseconds, that's actually not terrible per se. I don't know exactly what is the service that took that long time in the Quantel 95%. Let's refresh this. Uh-oh, okay. Let's go back to dashboards. I think the port forwarding broke again. I'm not sure what is making it break. I'm going to just start it again, and it might be too many requests. Okay, payment service. Can I dive deeper into the payment service itself? Okay, evaluation, event stream in the payment service. So I want to look at evaluation if I can. And there has been errors here. So yeah, so again, Jaeger lets you slowly like drill down more into figuring out exactly where something has gone wrong, how it has gone wrong. The tag, if you have more information like what kind of architecture it's running on and things like that, all of them are getting collected automatically. And like language of the process, all of these are coming from the OpenTelemetry collector. If you remember when we looked at the Go example, all of this was in JSON, like the description, runtime name, runtime version, all of these things. And Jaeger is collecting all of that per trace and putting that somewhere we can go easily take a look. I want to find a more, I don't know, let's look at a front end call, because that might have a bit more of um, the view that we're looking for, like the flow chart view that we're looking for. So yeah, one example here, we're making a front end GET request which has multiple call happening at the same time. So we call list recommendation, we call product catalog service, front end product catalog service, we have a product catalog service again, we have a multiple get product call as well as list recommendation. What the moment we refresh the page, and within each call we have this, like, now we have a smaller span. So the entire request end to end took say 12 milliseconds, and here we have this list recommendation took 7 of those milliseconds, right? So we could start seeing this is not the great example where it was super slow of something. So I'm going to try to find something that was, ooh, okay, it crashed again. You know what I'm going to do? kubectl get service. I'm going to just convert this proxy service into load balancer so that I can just go edit, go do it without port forwarding anything. Keep control, edit, service. There you go. Yeah, I'm going to change this to a load balancer. When you're using Kubernetes like this, do not manually change things like this. This is just for demo purposes. We're using Helm, so we would update some sort of like a Helm chart or values.yaml so that this becomes a load balancer. But we are trying to do it quick, so we're going to just like quickly manually edit this to a load balancer and wait until we have external IP here. Wait a few more seconds. Takes however long that takes. That is, here you go. So we have this 35 to 24 thing. Cool. We're gonna try to go to it. Colon 8080. Oh no. Okay, here you go. That worked. Jaeger UI. We want to go there. Okay, no more crashes anymore. That's good. We want to go to front end. We want to look for max duration of like min duration. I want to see something that was slow. So I want to see is min duration 4 seconds, find some traces. Now we have found some requests that took a really long time, like 15 seconds. So we can come and see exactly what caused it to get so slow. So one thing you're going to see that most of the stuff, like this one, this one, this one, all of them took like in milliseconds. And this one get product call, for some reason, took a really long time. So now you can see why that is happening. Okay, we have an error that is happening. Provider not ready, connection not made. So something has gone wrong, and we can now go see exactly why something took really long time. Yeah, so what traces lets us do is easily look at the request, find the delay, and exactly what caused that delay. So this was, I guess, like a very quick introduction and first looks at OpenTelemetry and setting up a language. We took a look at how to do this using like the Go programming language, setting trace and other things on your code itself, as well as take a look at like a fully fledged demo application that has a bunch of these moving parts all combined together. Yeah, that was fun. If you have any questions, drop it in the chat or in the video later. We can come back and answer. Also, take a try out yourself. I think this demo would also just work in Minikube or Kind. If you don't have like a cluster somewhere else, you can always run locally. This demo should just work there as well. It just asks for some resource that you need, like 6 gigabytes of free RAM. Other than that, it seems to not require too much resource. And that's pretty much it. Thank you so much for joining this episode of ChatLoopBackOff. Yeah, It was a lot of fun checking this new project, or not new project, checking this project out really in depth for the first time for myself. I've been a user of OpenTelemetry, but mostly from the other end, looking at the metrics and using the metrics, but setting them up manually this time was also interesting and fun. I asked the magic person in the background